need to deploy an OAuth-protected FastMCP server under a custom path prefix without breaking authentication or discovery endpoints. We'll configure the critical relationship between issuer URL, base URL, and MCP path to ensure OAuth metadata remains accessible at root while operational routes use your chosen prefix. You'll see how to avoid double path prefixes, properly mount well-known routes, and handle the tight coupling between discovery and operational endpoints through the auth provider, all while maintaining RFC compliance for OAuth flows. The pattern enables progressive adoption of MCP tools alongside existing APIs, with explicit warnings about common pitfalls like CORS conflicts and silent authentication failures. From FastMCP, import FastMCP. From FastMCP, server, auth providers, GitHub import GitHub provider. From Starlette, applications import Starlette. From Starlette, routing import mount. Hash define the routing structure. Root URL equals http://localhost 8000. Mount prefix equals /API. MCP path /MCP. This demonstrates the OAuth-compliant ASGI mounting pattern, where a FastMCP server with authentication requirements is integrated into a larger web application while maintaining RFC-compliant endpoint locations. The core challenge this solves is reconciling OAuth's requirement for root-level discovery endpoints with the common need to mount operational services under path prefixes. The solution uses explicit URL configuration through issuer URL and base URL parameters to maintain proper endpoint separation. The pattern works by creating two distinct routing layers: discovery routes mounted at the domain root for OAuth compliance, and operational routes, including MCP endpoints, mounted under a configurable prefix. The getWellKnownRoutes method generates the required well-known endpoints using the MCP path parameter to construct path-scoped metadata URLs, while the auth provider's issuer URL points to the root domain. This configuration prevents silent OAuth failures that occur when discovery endpoints return 404 errors due to incorrect path resolution. The hosting application's lifespan management comes directly from the FastMCP app to ensure proper session handling. This approach enables secure, standards-compliant deployment of MCP servers within existing applications while avoiding common pitfalls like double path prefixes or CORS middleware conflicts. The explicit separation of issuer URL, root, and base URL, prefixed, addresses the core tension between OAuth's discovery requirements and practical application routing needs. The pattern is particularly valuable when progressively adding MCP capabilities to existing systems, though it requires careful configuration to maintain the invariant that base URL plus MCP path equals the final operational endpoint location. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the framework that bridges Python functions to AI models as callable tools. It handles schema generation from type hints, input validation, and secure execution while maintaining OAuth 2 compliance. The framework enforces proper separation between discovery endpoints at root and operational routes under prefixes, preventing silent authentication failures that occur when well-known routes become inaccessible due to incorrect path mounting. From FastMCP, server, auth providers, GitHub import GitHub provider. This imports GitHub provider, FastMCP's OAuth 2 handler that requires two distinct URL configurations: issuer URL at root for discovery endpoints, and base URL with prefix for operational routes. The provider's getWellKnownRoutes uses MCP path to generate correctly scoped metadata URLs, preventing silent OAuth failures from malformed paths. Critical implementation note: never include the mount prefix in both base URL and MCP path. This creates double paths that break OAuth validation. The auth provider manages the tight coupling between discovery and operational routes while maintaining a unified API surface under the shared prefix. From Starlette, applications import Starlette. Imports Starlette, the ASGI framework foundation for FastMCP's HTTP layer. This handles core routing, middleware, and the lifespan management required for OAuth-compliant endpoints. The framework's mounting system enables proper separation between discovery endpoints at root and prefixed operational routes. From Starlette, routing import mount. Imports mount from Starlette, enabling sub-application mounting under URL prefixes. This solves the OAuth2 discovery problem, where issuer URLs must be root relative like http://localhost 8000, while operational endpoints use prefixes like /API/MCP, preventing silent authentication failures. The pattern avoids double path issues by ensuring the mount prefix appears exactly once in the final URL structure. Hash define the routing structure. Root URL equals http://localhost 8000. Sets the base URL for local development and OAuth issuer discovery. This must point to the server root without mount prefix, because OAuth providers require well-known endpoints at the domain root, while operational routes use the prefix paths. Incorrect configuration here causes silent OAuth failures and metadata resolution errors. Mount prefix equals /API. Defines the API root prefix for all operational endpoints under /API. The auth provider requires this to construct correct path-scoped well-known URLs, while keeping the issuer URL at root for OAuth discovery compliance. Critical: never include this prefix in both base URL and MCP path, or you'll create broken double paths that silently fail OAuth flows. MCP path/MCP defines the operational path prefix for FastMCP's tool endpoints. This must match the base URL configuration in your auth provider, while issuer URL remains at root for OAuth discovery. The auth provider uses MCP path to generate correct path-scoped well-known URLs, preventing silent OAuth failures from mismatched endpoints. OAuth-protected mounting pattern. The issuer URL anchors discovery at root, while base URL scopes operational endpoints under prefixes, requiring explicit root separation through get well-known routes. Including the mount prefix in both base URL and MCP path creates double prefixed routes that silently break OAuth flows. The auth provider's get well-known routes method constructs path-scoped metadata URLs using MCP path, ensuring RFC-compliant discovery while maintaining prefix isolation.
The prefix that divides the routes unites the protocol.